everyone, welcome to MakerFun powered by Brilliant Labs. I'm Nellie and I'm so glad you could be here with us. I love colors. My favorite color is blue, but I especially like it when there's lots of colors jumbled up together. What pops into your head when you think about colors? Do you imagine a rainbow or mixing paints together? Do you imagine fireworks or neon lights or jelly beans? Where do colors even come from in the first place? In fact, colors are just different types of light that make its way into our eyes. Light is made up of waves. Some are longer waves, and some are shorter waves, and some are kind of in between. When light is white, like from the sun, all these different lengths of waves, they travel together. But sometimes the waves hit something that break them up into different sections. Those sections of light are colors, and they're grouped by the length of their waves. Longer wavelengths look more like red, and short wavelengths look more like blue, and the ones in between are the other colors, like orange, yellow, and green. There are even other wavelengths, longer than the red and shorter than the blue, that we can't see with our human eyes. But we have innovative technology that helps us see those wavelengths, like infrared cameras. Light seems to follow its own set of rules. For example, light travels faster than anything else in the universe, and nothing else even comes close to it. Light shines in straight lines and bounces off of different things, and every time it makes a bounce, it changes a little bit depending on what it bounced off. Some things reflect all the light, like this mirror. Other things absorb some of the light, like my hand. Some things let all the light through, like my glasses, and some things bend the light and change it, like this crystal. The science of light is called optics, like as in an optical illusion, and we're going to explore optics today. We'll make a sun catcher, mix our own paints, check out some LED lights. Oh, and in just a moment, I'm going to show you how to bend light and make a weird optical illusion called a big face box. So grab some materials and join in with us. from PEI is going to show us how to mix our own colors.
Hi everyone! Today we're going to do some fun exploration with pigment and color. We just have a regular blue, yellow, and red. This is probably the most commonly used colors to create our color wheel. Color wheels are a great way for us to create many colors out of just these three primary colors. And so what I'm doing here is I'm setting up my color wheel to have 12 spaces. And we are going to use, let's start with red. And we're going to skip. So every third spot will get a primary color. And now we're going to skip 3 spots and we're going to go with our third primary color. So 1, 2, 3. So blue is going to go here. So I have a mixing tray that I'm going to use because what I want to do is I want to create our secondary colors. And these are colors that happen when we mix. We will get this color. Can you guess what it'll be? So in order for us to do that, I'm going to put some yellow onto my mixing tray. And now we're going to put some red. And let's see. So actually, that looks like a really nice orange, doesn't it? So this is a secondary color, and I'm going to take a little bit of that secondary color and I put it over here. And I add a little bit more red to it. We're looking for a color that would go somewhere in between this orange and this red. So really kind of tomatoey color. Darker than this one, but lighter than that one. And this would be called a tertiary color. So like primary means first, secondary means second, tertiary means third. All right, now we need to get this orange to be in between yellow and orange. So same process. I'm going to take a little bit of this orange, I'm going to bring it over here, and I'm going to add more yellow. Next, we can still play with the yellow actually, and we're going to try to get the secondary color when you mix blue and yellow. Can you see what color that is? It's a lovely shade of green. Awesome. So this is your standard red, blue, and yellow color wheel. And the theory is that you can mix your primary colors, your red and your yellow, to get an orange, and your red and your blue to get a purple, and your blue and your yellow to get a green. So this would be your secondary. This would be a tertiary and a tertiary. Primary, primary. This is our secondary here. And our secondary here. Tertiary, tertiary. Primary, tertiary, tertiary.
Most of us have seen LED screens before. Computers, tablets, phones, and televisions have LED screens. LED stands for light emitting diode, and the great thing is, they only come in 3 colors: red, blue, and green. You'll be able to see how those 3 colors are carefully mixed together to create all the colors you can see on a screen. You'll see that all of these tiny, tiny lights are either red, blue, or green. But our logo is actually purple and turquoise and yellow. So how are we going to get purple, turquoise, and yellow with red, blue, and green? You can see for every different color, certain LEDs are lit up brightly or dimmed down to almost nothing. Coming up next, Helene from New Brunswick is going to show us how to make our own paints out of things we find in nature.
Here's what you need to make natural paints. Blueberries,
bleuets,
dandelions,
pissenlit,
coffee,
café,
turmeric,
curcuma,
Please ask an adult to pour hot water in the jars. Lawn clippings,
gazon,
tea,
thé,
red onion,
oignon rouge,
beet juice,
jus de betterave,
let cool for an hour. Experiment different techniques using different colors. Test how your natural paints work on different paper. Make sure you clean up after you're done.
Did you know that the light from the sun can be used to make energy? You may have heard of solar power and solar panels, but plants have been using solar energy long before we came along. Their solar panels are called leaves, and Lauren is here to tell us how they do it.
Hi everyone, my name is Lauren. Did you know that sunlight is an extremely important source of energy? Humans use the sunlight for lots of different things. Plants use the sunlight to make food in a process called photosynthesis. That means that while animals, like people, have to eat food to survive, plants are able to make their own. If you break down the word photosynthesis, it's made up of photo, which means light, and synthesis, which means putting parts together to make something. So together, photosynthesis means making something using light. But what else is used in photosynthesis? The first part is water. You may have seen people watering plants before. Water travels into a plant up through a part called its roots. The next part is carbon dioxide. Carbon dioxide is a gas in the air. We actually release carbon dioxide into the air when we breathe out. Carbon dioxide enters the plant through a part of its leaves called the stomata. The third part is sunlight. Sunlight enters the plant through a part called the chloroplast, where it takes the energy from this sunlight and uses it to transform the water and carbon dioxide into food. To make this happen, water and carbon dioxide take part in a chemical reaction. That means the pieces that make up water and carbon dioxide get mixed up and turned into something new. In this case, they make oxygen, which the plant doesn't need and releases back into the air, and sugar, which the plant uses as food. And this whole process is powered by sunlight. So the three things a plant needs to make food are water, carbon dioxide, and sunlight. A great way to see plants growing and thriving using this process is by exploring plant life outside. You can see all kinds of different plants that use photosynthesis to live. But if you want to bring the fun inside, you can also easily grow your own plants indoors. This is one of the plants that I grow inside. It's called a philodendron, but I call it Phil for short. Phil uses sunlight to make food. Usually you can't see a plant's roots because they're in soil, but Phil started off as just these leaves that I cut off another plant. So putting them in just water in a jar has allowed the roots to grow. Here you can see Phil's roots that collect water and leaves which collect carbon dioxide and sunlight. If you want to grow your own plants inside, one way of doing that is by planting seeds. I'm going to be planting these alyssum seeds, but you can also get seeds to grow from fruit like apples, tomatoes, lemons, and peppers. Different seeds need different things to grow. For mine, I'm going to be placing them on top of damp soil, and I'm not going to be covering them, but I'm just going to gently press them into the soil to make sure they make contact. Light and color are connected. The sun gives off white light, which contains every color of the rainbow. We see things as different colors depending on what part of this light they absorb and what part they reflect. So green leaves appear to be green because they contain something called chlorophyll, which absorbs mainly red and blue light, which means that the light it reflects, or the light that we see, appears to be green. I hope you've had fun learning about how light and color are important to plants and how they make food using photosynthesis, and that you go out and explore the plant life around you, and even grow some of your own inside.
Here's special guest Sarah from New Brunswick to show us how she makes her own colorful bath bombs.
So who's ready for some bath time chemistry? Sometimes taking your regular old bath can get a little boring, so it's fun to add some bath fizzies or bath bombs to your water. But how exactly do these work, and why can't we just use anything at all? To understand this, we need to take a look at pH levels, which you might have heard of before. pH is measured on a scale similar to, say, a scale for weight or a thermometer for temperature. In this case, we use a scale from 0 to 14, with 7 being in the middle and neutral. Anything below 7 is considered acid. Anything above 7 is considered a base. You may have also heard the terms acidic and alkaline, which mean the same thing. Some everyday things in our lives are considered acidic or alkaline. Lemons and tomatoes are great examples of acidic foods, which we often refer to as sour. And baking soda and soap are some alkalines in your home, which we would consider to be bitter. Not all acids and bases can be safe like our food, though. Some things, like the inside of batteries or cleaning supplies, can be dangerous. People like you and I have a mostly neutral pH, so our bodies don't like anything too high or too low on the pH scale. So what does any of this have to do with our bath bombs? Well, if we take a base and we add an acid in a solution of water, which would be our bath, it's going to make a chemical reaction, which is the fizz that we see and the real fun part of the bath bomb. You're going to want to look for the buttons on your scale that say unit and Z or T for tare and your on and off button. You will want the unit to be in grams, and you'll likely see a little G in the corner or somewhere on the screen. You can find household things to be molds, like this 2-part Christmas ornament, or you can get bath bomb molds like these aluminum ones that come in a variety of sizes. Hard silicone molds like these work very well, while soft ones like these will make your bath bombs fall apart when they dry. Though we're not going to use colors today in our recipe, you can use something like this skin-safe mica. It's an artificially colored mineral, just like you would find in lipstick or eyeshadow. You can also use specialty dyes called lakes that are intended specifically for bath bombs. Because the colors are limited, of course you're going to have to mix them to make other colors that you don't see. Let's start mixing our basic ingredients and get these bath bombs going. We're going to start with 300 grams of baking soda. To that, we're going to add 75 grams of citric acid. Between each ingredient, I actually press the 0 or tare button to put the scale back at 0. I'm now adding 15 grams of cornstarch and 5 grams of cream of tartar. Both of these things will help the bath bombs harden as they dry. We're going to measure out 25 grams of witch hazel or alcohol, but we're not going to use it all. It's best to have enough on hand though. We're slowly going to add the liquid in with a spoon. Very, very slowly, and mix the entire time. You don't want the liquid to sit on the powder for any length of time because it might activate it, but you don't want it activated until it hits your bathtub. Squeeze some of the mixture periodically to make sure it stays together. If it doesn't, add a little more liquid, mix, and try again. It's now ready for your molds. You're going to overfill both sides of your mold so that you can squish it together nice and compact. You can even hide a bath-safe toy inside of a large bath bomb as a fun surprise. Now just let your bath bombs dry for a couple of days on an egg carton or a tray, and they'll be all set to use. Here's a secret surprise bath bomb that we made. And here's a green one that I made on my own. But I didn't have green bath bomb color. How do you think I made it?
I'm going to go outside with these 2 crystals to play with the sunshine and see what we can do to bend the light. Let's see how many different ways we can make a rainbow.
When sunlight moves through a prism, it splits into a rainbow. This happens because of something called refraction. Think about how fast you can run on the sidewalk compared to on sand or gravel. You can't go as fast on sand or gravel because it's harder to move through. The same thing happens when light moves through a prism. When light changes from moving through air to moving through something like glass or water, it slows down. If this change happens on an angle, the change of speed will cause the light to bend. This bending is called refraction. Sunlight is made up of every color of the rainbow, and all of the colors act a little differently. When sunlight bends, the red part of it bends the least, the violet part bends the most, and every other color bends somewhere in between. That is what makes the rainbow we see on the other side.
We've had a big show exploring optics today. I want to thank everyone who helped make this episode possible and our special guests for showing up and bringing their maker energy. Show us what you're doing with your maker energy. We'd love to hear from you and show other people what you've done. Find us on our social media, on our website, brilliantlabs.ca, and you can even send us snail mail. I'm really looking forward to seeing what you're bringing with your energy. Stay brilliant, and I'll see you next time.